It's a pleasure to meet everyone, my beloved friends and lecturers. Today, we are going to make a presentation about topic 2.1 differentiation. Okay? Before that, let me introduce my teammates who was Muhammad Khairul Nizam bin Kamarudin. Their register number is 09DEE 20F 2012. That is me, Ishwar Anak Laki Rama 09DEE 20F 2002. Followed by Nick Hadli bin Nick Harman 09DEE 20F 2012. Followed by Muhammad Asfar bin Muhammad Faizan 09DEE 20F 2013. So, I will pass to Muhammad Nizam after this. Thank you.
Thank you, Eswa, for the introduction. Let me start my presentation. First, what is differentiation? Differentiation is technique which can be used for analyzing the way in which function change. In particular, it measures how rapidly a function is changing at any point. In engineering application, the function may, for example, represent the magnetic field strength of a motor, the value across a capacitor, the temperature of a chemical mix, and so on. It is often important to know how quickly this quantity change. Next, in the chapter, we explain what is meant by gradient of a curve and introduce differentiation as a method for finding the gradient at any point. After that, application of differentiation. Differentiation is used widely to help us to solve many types of real-world problems. One of them in determining the maximum and minimum values of particular function. Cost, stretch, amount of material used in a building, profit and loss. The process in finding the maximum or minimum value is called optimization.
Okay, thank you from Khairul Nizam. Okay, now I will be presenting about how to find the maximum and minimum point using the differentiation. In this section, we will be the same example problem of finding maximum and minimum value of finding the functions. Okay, we will go step by step. First, differentiate the given function. Second will be the let fx 0 and find the critical numbers. Third will be find the second defined, which is fx. Fourth, apply those of critical number to the second linear equation. Fifth, the function fx maximum will be the function less than 0. The sixth will be the function of minimum, which is more than 0. Seventh will be to find the maximum and minimum point to make a beautiful graph from the answer we determined. Okay, now we will see the question. Find the coordinate of the stationary point on the curve, which is y equals to x square minus x minus 6, and determine their nature. Third will be the graph. Solution. Stationary point y equals to x square minus x minus 6. First, as I said, dy over dx, which is derivation, equals to 2x minus 1. We take from above. X square will be 2x and single x will be negative 1. At the stationary point, dy over dx equals to 0. 2x minus 1 equals to 0. So the 1 will be opposite. So bring another side. 2x equals to 1. So 1 can be divided with 2. So 2 bring over, which is x equals to 1 over 2. Second, we will see when x equals to 1 over 2, y will be, okay, insert the answer to x, replace it. So y will be 1 over 2 square minus 1 over 2 minus 6. So answer will be 1 over 4 minus 1 over 2 minus 6. The final answer will be negative 25 over 4. Therefore, the stationary point is 1 over 2 and negative 25 over 4. That's all from me. Thank you. Next will be Nick Adli. Will be continuing the same question, but for different kind of solutions.
Okay, thank you Asfar, and I'm Nika Rahman, and I will continue the next step. For the first, determine the nature of the stationary point. So, dy over dx equal to x minus 1. So, we differentiate in d square y over dx square, we got 2, and d square y over dx square, we got 0. So the point we got 1 over 2, and also we got 25 over 4. Oh, sorry, we got minus 25 over 4 for the minimum point. So now we determine the x intercept when y equals 0. So 0 equal x squared minus x and minus 6. We bring over x squared minus x and minus 6 equal 0. The answer will be x plus 2 and x minus 3. So now we start with graph. So here we can see we have 3 reading. For the first reading, negative 2, 0, and second 1 over 2, negative 25 over 4, and the third we got 3, 0. So that's all for me. So I will pass for Iswa.
Okay, before we end our presentation, there will be Q&A section. Okay, let me go for the question first. So, stationary point, what is y equal to x squared minus x minus 6? dy per dx equal to 2x minus 1. At the stationary point, dy per dx equal to 0. 2x minus 1 equal to 0. So the x will be x equal to 1 over 2. So, is there anyone willing to complete the question?
Okay, now I will answer the question from Iswa. So, the question x equal 1 over 2. For the solution, okay, y 1 over 2 square minus 1 over 2 and minus 6. So we got 1 over 4 minus 1 over 2 and minus 6, and the total we got 25. The total negative 25 over 4. For the stationary point, we got 1 over 2, and also we got negative 25 over 4. Okay, that's all for us, and thank you for watching.